Measurements in a nutshell. So what are measurements? Basically, things we do in a science laboratory or any kind of situation where we want to know the value of something, like how big is it, how tall is it, how much does it weigh. Here we're trying to figure out what the mass of this chocolate is. One thing you want to notice about it is that between the chocolate and the balance, there's a weigh boat. You never want to put an item directly on a balance when you're measuring the mass because you'll contaminate the balance, something you should know. All right, make your measurement. So a measurement needs two things. It needs a number and a unit. A number itself is really inadequate because it doesn't tell us anything. If I just tell you I'm going to give you 50, you would just look at me like, 50 what? You need to have a unit to correspond with. If I say give you 50 points, you'd be like, yay, that's wonderful. So here's some examples of measurements. 35 meters. By seeing the word meter, we know we're probably using a tape measure or some sort of measurement tool that measures length, right? For 0.25 liters, we're probably using something like a graduate cylinder, which measures volume. 225 pounds looks like a household scale. That's how you usually weigh yourself. And 3.4 hours, time. So you're probably using a clock or a watch or something. The unit is very important because it helps narrow down our options. Now, for us in the U.S., we have a multitude of different options for measurements. For example, we have pounds, we have kilograms, we have grams, we have ounces, we have a whole variety. Majority of those the rest of the world does not use, other than the kilograms. That's the only thing the rest of the world uses. We're the only country that uses what's called non-metric prefixes predominantly. So when you say there's 50 miles between here and X, most people around the world have no idea what a mile is. They know what a kilometer is, but they don't know what a mile is because mile is unique to the U.S. And that's the issue, is that the rest of the world uses what's called the metric prefixes. We do not. So why do you need to know them? Because in science, we use metric prefixes predominantly. You need to be familiar with them. So what are some metric prefixes? So the first thing you understand about a prefix is just a sequence of letters that represents a number. So when you see the word tera, you're looking with 1, with 3, 6, 9, 12, 0. That's a huge number. Giga, which you all know from your phones and other devices, because that's how you store memory, gigabyte, it represents a billion. So the word giga, or the prefix giga, means a billion. So whenever you see giga anything, you think a billion of something. Like a giga dollar would be wonderful, right? Mega, same thing, 1 million. So all these prefixes have a number they correspond to. That's what makes it such a simple system. By just knowing a set number of prefixes, you know all the different possibilities for the measurement. And that makes life a lot easier. Fortunately, we do not want to make life easier in the U.S., so we have a variety. So we're going to talk about the ones that increase the units. These are the ones you need to be responsible for. So giga means a billion, so 1 with 9 zeros. So the example is that there is 1 billion meters in 1 gigameter. That's the relationship you need to know. Mega is represented by the big M and represents a million. So a million liters is equal to 1 megaliter. Kilo is 1,000. 1,000 grams equals 1 kilogram. The prefix that decreases a unit, on the other hand, deci is 0.1. So there's 0.1 meters in 1 decimeter. Centi is 0.01. There's 0.01 liters in 1 centiliter. You notice the way I set this up, all they're equal to one of these units, 1 gigameter, 1 megaliter, 1 kilogram, 1 decimeter, 1 centimeter. I'm telling you how many of these base units are in there. So how many liters are in 1 centiliter? And that's the way you want to look at the relationship. We have milligram, and that's 0.001 grams is equal to 1 milligram. So these are all the prefixes you need to know. So you need to understand what the symbol is, the capital letters. You need to know what this one is, DCM. So these are lowercase, K being lowercase, not uppercase. You need to know what the number value is and the relationship, because that's going to be used for any kind of calculation. All right, some base units that you'll be using for the metric system. So for length, we're going to use the meter. For volume, we're going to use the liter. The base unit for mass is the kilogram, not the gram. See, all these are meter, liter, gram, but the base unit for mass is a kilogram, not a gram, which is interesting. Time is seconds and temperature is Kelvin. So these are units we're going to be using. We're not going to use cubic meters. We're going to use the liter because it's a lot easier. We're not going to really worry about time for now. And mass, it's going to be very common. We're going to be predominantly in grams because that's what the most common unit for mass we're going to be using is. All right, so for length measurement, this is a meter stick and this is a yardstick. This is in feet, which the rest of the world doesn't use. This is in meters, which the rest of the world does use. You can see 1 meter equals 39.4 inches. A meter is about the distance from the ground to your waist, typically, for the average person. For volume measurements, we're going to use the graduated cylinder. So how do we use the graduated cylinder? We look to see where the meniscus is. Here it's really hard to tell. It's usually like a little valley-looking thing on the graduated cylinder. You can't really see it in this situation. But this is 1,000 milliliters or 1 liter. The relationship you need to know for volume is that there's 1 cubic centimeter equals 1 milliliter. They're synonymous. They're the same thing. So if I tell you 1 milliliter, it's the same thing as me saying 1 cubic centimeter. In hospitals, you hear the cubic centimeter used more than milliliters, but they're the same exact value. So remember that. It's measured using graduate cylinder, and only graduate cylinder, not a beaker, not a flask. We use this to measure volume. For mass, of course, we use a balance, and this is a pretty accurate one because it measures all the way to the thousandth place. For temperature, we're going to be measuring in Celsius and Kelvin, and you need to understand how to go between Celsius and Kelvin. So to go from Celsius to Kelvin, add 273. So for example, 300 degrees Celsius is equal to 573 Kelvin. How did I get that, you ask? All you have to do is just add the numbers. So you're going to take 300 plus 273, and voila, 573 Kelvin. Notice it's not degrees Kelvin, it's just Kelvin. That's how we go from Celsius to Kelvin. Going between prefixes, a common thing we're going to need to do, we're going to use what's called a T-chart. So how many centimeters are in 200 meters? So you're probably asking yourself, okay, how do I do this? So we're going to use a T-chart to help organize ourselves. So I'm going to explain the T-chart to you. The T-chart is designed to go from one unit to another unit. I'm going to go from meters to centimeters. So how do I do that? Whatever they give you goes in the upper left-hand part of the T-chart. That's here. Whatever unit you're looking for goes in the upper right-hand corner. And this is what I got from the metric prefix table I showed you earlier. We found there's 1 centimeter is equal to 0.01 meters. So mathematically, all you're doing, 200 times 1. So whatever's on top, you multiply, and you divide it by the bottom, 0.01. So when I do that, I get 20,000 centimeters. That's how you go between units. You use this T-chart. We'll be using this T-chart a lot this year, so it's good to be familiar with it. Once again, whatever you're looking for goes in the upper right-hand corner, which is here. Whatever unit you're starting with goes here, and this is basically equivalent. This comes from that set of relationships I showed you guys in the table. To make sure you did it correctly, all you have to do, make sure the unit you're starting with cancels out, like it does here. That's what we know we did correctly. And the unit you're looking for is on top. You're good to go. That's all you got to do. So features, whatever you are starting with goes in the upper left-hand corner. Whatever prefix you're looking for goes in the upper right. Units should cancel, and you multiply by numbers on top, divide by those on the bottom. So that's what I basically did here. I ended up with the correct answer. So let's try some more questions. How many liters are in 100 megaliter? Well, we know that whatever we start with goes in the upper left-hand corner. So what is the relationship? So the relationship is that there is exactly 1 million liters in 1 megaliter. So 1 megaliter, 6 zeros, 1, 2, 3, 4, 5, 6, in 1 liter. So we're going from megaliter to liters. So we know that we did it correctly because you see how the units cancel out? And look at the unit you're looking for is on top. So when you do the math for it, you get this. 1 with a lot of zeros behind it. And that's because you're multiplying 100 times a million. So basically, you're going to have a total of 8 zeros. And that's what this is showing you. What about this one? Well, 400 grams, upper left-hand corner, right? Then we need to write the relationship between milligrams and grams that we got from the chart. And when we do that, We know there's 0.001 grams, 1 milligram. Notice the units cancel. That's when we know we did it correctly. Now the math. 400 times 1 divided by 0.001. You can do it in your calculator, and you get 400,000 milligrams. Simple math. All right, next one. You're starting with this, which is 1, 2, 3, 4, 5. That's 1 million meters. So 1 million meters goes in the upper left-hand corner like it always will, whatever you're starting with, right? What are we looking for? We're looking for a gigameter, so gigameter should be up here, and then we'll have the relationship. So the relationship that in 1 gigameter, there's exactly 1 billion meters. That's 9 zeros. So we take 1 million times 1 divided by 1 billion, and we get 0.01. We know we did it correctly once again because the units cancel out. What we're looking for is on top. Beautiful. It takes a little while to get accustomed to this, but the sooner you get accustomed to this, the better, because you use it anytime you're going between units, and also we're going to be using extensively later in the semester when we do this kind of calculations. All right, the last thing I want to go over is density. So density is basically mass over volume. It's representing how much matter occupies a specific amount of space. So the formula is D equals M over V. D is your density, M is your mass, V is your volume. So the density of copper is 8.94 grams per cubic centimeter, which, by the way, remember, is the same thing as saying 8.94 grams per milliliter, because centimeter cubed and milliliter are the exact same thing. So how do we figure it out? Well, we know it's 8.94 grams, and to get our volume, length times width times height, and that gives us our volume, which is 1 cubic centimeter. So we just divide in, that's our density. So it's a pretty dense substance, so this will sink in water. Water has a density of about 1 gram per milliliter, so this will definitely sink. All right, let's try our practice problem. Calculate the density of a metal sample with a mass of 8.96 and a volume of 4.31 cubic centimeters. So what do you need to do first? Write the formula. D equals M over V. What is our mass? 18.96. What is our volume? 4.31 cubic centimeters. So I have to just divide those two, and you get 8.96 divided by 4.31. The units turn into just grams per cubic centimeter. That's the units for density. So please don't try to cancel them or change them to something else. Just put this over this, and you're done. 18.6 divided by 4.31 gives 4.4. So that's the density of this object. And that's how we do density calculations.